Hello there, this is Will Patillo, and today I would like to demonstrate for you some of the progress I've made recently on a neural network visualizer. So what we have right here are some predefined inputs and outputs that are in the scene. These are my inputs over here, output over here. I can click, drag, and move them around. You can see in green is the one that I have selected. I can select single or multiple, so if there's multiple, then I can drag them around, multiple at a time. And then right-click to unselect. I also have hotkeys to be able to switch between single and multiple. With one selected or with multiple selected, I can press branch or B hotkey to create new cells off of existing ones. Then I can also connect specific cells to other cells. So let's say I want to connect this one to this one over here. I have two different groups, an input group and an output group. So that which is selected in green is input. One selected in red are output nodes. So I have a green here, red here. This one is bigger right now because that's what will move around if I click and drag. If I switch to input, now this one is highlighted. If I press connect, then that'll connect all the inputs that I have selected to the outputs. I can also disconnect by pressing the D right there, and that'll disconnect all of those. So let's say if I switch to this one, I can disconnect that, or disconnect this to here. And I can also deal with multiple connections or disconnections at once. So let's see, I'll disconnect this one here and move some of these around. So let's say I have a group of 3 like this. I can select multiple, get both of these inputs, select all of these outputs here, and now when I press connect, it connects each input to each of these outputs. I can connect these over here. Select them all, select that one, and connect. And again, this also works for disconnections. You can get multiple at once. And then lastly, I can destroy cells. So let's say if I just select this one, for example, and then destroy it, then it disappears and all the connections go with it. I can do the same thing for selecting multiple at once and destroy, and those are all gone. So one thing you may have noticed is this little box up here. This shows a bit of information as to what is going on inside of the cell. And this will demonstrate just whichever cell I have selected. This does not work if I have multiple cells selected. It's only if there is one. And it also works whether I'm looking at input or at output nodes. So that'll show this one, and if I switch over to input, now it's showing this one. As I press the spacebar, these inputs will light up in a consistent pattern, and this is essentially following a truth table. So it's counting in binary. So right now we have a 0, 0, now it's a 0, 1, now 1, 0, now 1, 1. And for those who aren't familiar with binary, that's counting from 0 to 1 to 2 to 3, and then cycling back down to 0. And just focusing in on this cell, we can see what value is being held in it. So right now there's a 0 in there, now there is a 1 in here, and a 0 in here. Now there is a 0 in here, and a 1 in here, and now there's a 1 in both of them. I'm going to branch this cell out and connect this one over here. These connections are directional. It takes a signal and sends it from here out here. So actually if I step through these, we can see the signal moving from these inputs to this intermediate node right here. And before a signal goes from here over to here, it gets processed by these receiver nodes. And these receiver nodes apply a weight. That is, it multiplies the incoming value by whatever number is inside the receiver and then passes that along to the next cell. So to demonstrate that, I'm going to take one of these and I'm going to bring it down and make it a -1. So you'll see that this has just changed color to red. As I move this one around, that lower one changes color, If I move this one, then that one changes color. So now we have this intermediate cell right here. It has a weight of 1 from this cell and a weight of -1 from this cell. And we'll see what happens as I step through these. So right here we have a 1 inside of this cell. It passes that 1 over here. It gets multiplied by 1, so stays as a 1. Then when I cycle to the next, we send a 1 from over here. It gets multiplied by -1, and now this cell has a -1 inside of it. Now when I step to both of these, we're getting 1 times 1, it's 1 over here, and a 1 times -1, -1, and these cancel each other out, leaving 0 in this cell. If I change these around a little bit, to say something like that, and I step through these again, now we'll have a 0.419 in this cell, because it's 1 minus 0.58. The other thing that is this bias over here. So to illustrate that, I'm going to connect this node out over to my final output over here. And what a bias does is it changes what the cell sends out after the value of the cell changes. Say I'll give it a bias of 1. I'll make both of these inputs negative, just slightly negative, and have a bias of positive 1. And now we'll see that this is outputting a 1 despite having a negative value in here. And there's actually two things going on with that. One is the cell right now is getting a -0.6 because of the modified values coming into it. But then after it has that -0.6, it adds 1 to that. So what it really is outputting is a 0.4. Now, you'll see, however, that this is getting a 1. So how did that 0.4 change into a 1? Well, the reason for that is another thing that isn't visualized right now, which is the activation function. Right now, this system is using a binary step function, where if the value that's in the cell is 0 or less than 0, like as in here, then it sends out a 0. If it's greater than 0, then it sends out a 1. So in this case, because the bias is 1 and it's never going to be less than 0, so this is always outputting a 1. So if I shrink this down a little bit, then this will output a 0 when this cell value is less than its bias.